Hello, I just want to give a video update. This is by no means one of the milestones or anything like that. It's more of just a proof of concept going in the right direction. The oscillator or the coil is oscillating at roughly 300 kilohertz in that ballpark. It's 25 turns of number 38 wire. Like I said, this is just a proof of concept. I've got a transistor circuit that I've used in the past, very reliable to generate a signal like that. It's a 3 transistor combination to produce a signal that rails to rail from 0 to 5 volts, which is nice for a micro to see. You can see the scope as far as the can external to the coil. Where it's most sensitive is in the center of the coil, and you can see as far as it changing, and it's pretty stable once it's there, so it's a pretty nice signal to deal with as far as with the micro. I get like a can of tomato soup or tomato paste. Still, it shows the same. It's not as much as the can because it's a little bit smaller. But you can see that it changes, and it changes quite a bit as far as, oh, about knocked my coil off. It changes quite a bit. Here is a bottle of plastic water. You can see that it does have no effect on the coil itself. And just to make sure I didn't kill my coil, I'll put the can back in place. So just wanted to give you a heads up as far as that goes. The micro will be basically how the scope is handling, and you see all the motion on the scope. The micro, in a sense, will be programmed to interact in a very similar way. There is a slight amount of drift, and I think I can compensate that, or I'm pretty sure I can compensate that in the software. But you'll have to tar it, you'll have a button to press, and it basically zeroes it out like a scale, and you call that normal. You do that without any metal presence. And then you have a can or any kind of a metal, and it causes a significant variance that can be detected and show either a red light or green light, depending on if there's metal or not present. So that's it for now. I just wanted to show the coil and the operation. It is on a little bit of a stand so that it is up above, so the can is actually going partially through the coil. But there's sensitivity pretty high. I can show you where that is. As far as above the coil. Now that's level with the coil. And so this is probably, by the looks of it, it's about 4 inches or so is where it starts to cause a deviation. Now you'll be able to tune that by tuning the threshold. That's what the tuning would be for. Once you tar it, then you'll have a knob that you can turn for setting the threshold as far as when it actually detects the metal that's within the center of the coil. Now outside of the coil, it has a just knocked part of my deal off. I have to be careful. I'm trying to hold the phone and do this at the same time, so my perspective is a little bit off. So if I move the can near the coil, it changes it a little bit, but not anything like what it does to the center of the coil. And that's the goal, is that we want the center of the coil to be where the most sensitivity is. So outside of that, you were asking as far as, adjacent metal. But once you tar it, any adjacent metal that you have in your design will be normalized to that value. So as long as that doesn't change, then it's only going to be sensitive to metal within inside of the coil. All right. Thanks. Bye.